Let's go back to the problem that we were starting at the end of the last video. In this problem, a mean isn't being calculated. Instead, a proportion is being calculated. So I need to explain what a proportion is. So a proportion is just a percentage written as a decimal. So imagine that there's a group of people that's 40% male. You could say that the proportion of males in that group is zero point 0.4. It's 0.4 male. Or imagine that there's a group of people that's 35% male. The proportion of males in that group would be 0.35. It's 0.35 male. Like I said, a proportion is just a percentage written as a decimal. In this situation, we have a population of 4 people that have these 4 genders: male, male, female, and female. And um, a person is randomly selecting 2 of the 4 people. The person is going to record the 2 genders, and the person is going to calculate the proportion of males in the sample. In other words, a person is going to count the number of males in the sample and divide by 2. So if the sample ends up being 2 males, that's 2 males divided by 2, which would be 1, which means 100% male. If the 2 genders end up being male and female, then it's 1 male out of 2 people. So 1 divided by 2 is 0.5. The proportion is 0.5 male. In this situation, we're going to list out the possible samples again, just like we did in the first problem. And just like in the first problem, it's 2 people out of 4 people. That means that the possible samples are the same. It's still person 1 and 2, 1 and 3, 1 and 4, and so on, all the way up to 3 and 4. Just like in problem 1, we're going to fill in the data. So instead of filling in ages, we're filling in genders. Person 1 and 2 are 2 males. Person 1 and 3 are male and female. We're doing that for all 6 possible samples. Then once the genders are filled in, we need to calculate the proportion of males in each of these possible samples. Let's start with sample 1. So this is 2 males out of 2 people. 2 divided by 2 is 1. It's 100% male. This is male female. 1 male divided by 2 is 0.5. So this is 0.5 male. This is also 0.5 male. It's 1 divided by 2. They're actually all 0.5 all the way up to sample 5. In sample 6, we have 0 males. So it's 0 divided by 2, which would be 0. This just means that the sample is 0% male. Like I said, for each of these, you just count the males, then divide that number by 2. And then we list out the answers here, and that's our sampling distribution. Now we can go and make the graph like we did in the other problems. Here, I'm going to I'm going to plot the 6 answers. So sample 1 was 0. The next 4 samples were all 0.5, and the next sample was 1, 100% male. And this tells us the probabilities. When the 2 people are randomly selected, there's a 1/6 probability of the sample being 0% male or all female right here. There is a 4/6 probability of the sample being half male, 0.5, and there's a 1/6 probability of the sample being all male, or 1. The probabilities are 1/6, 4/6, 1/6. Like I said, the sampling distribution gives you the probabilities of all possible outcomes of the random sample. You might be wondering why I put p hat right here. And I'm gonna be posting a video that explains what these symbols are. I need to explain the symbols that we're gonna be using in our class. Each statistic that we're using has its own symbol, and the symbol for a sample proportion is p with a little hat. It's called p hat actually. So p hat is sample proportion, and sample mean is x bar. It's an x with a bar above it. Just remember, sample mean is x bar, sample proportion is p hat. That's why I put x bars in this graph to show that there's sample means being plotted, and in this graph I put p hats to show that there are proportions. Now let's move on to well, here I have the probabilities just shown above the graph. Let's move on to cover the main points that I want you to know about sampling distributions, and then that'll wrap up this topic. So here's our first point. In a sampling distribution of sample means, the mean of the sampling distribution is equal to the mean of the population. So here's some symbols that I need to explain. So this symbol it looks like a U, but it's actually mu. This is the symbol for population mean. So mu is population mean. It's a Greek letter. X bar is sample mean. So sample and population. What this is saying right here is mu x bar, which means it's actually the mean of the sample means. It's the mean of the means. So remember in the problems that we did, that each sampling, remember in problems 1 and 2, the sampling distribution was completely made up of sample means. It was the mean of all 6 possible samples. So it's really just the mean of the sampling distribution is just the mean of a bunch of sample means. And that, what I'm saying here is that equals the population mean. So let me just show you a couple of examples of what I mean here. Let's go back to some of our examples up here. So here was our first diagram. We have a population of 4 people. And here we have our sampling distribution, which is the means of all possible samples. If you wanted to get the mean of the population, you would add their 4 ages and divide the total by 4. So let's see what it would come out to. 20, 50, 90, 140 divided by 4. It would be 35 right here in the center. The population mean is 35 in this situation. Now let's get the mean of the sampling distribution. So remember that the sampling distribution is just the means of all possible samples in this situation. So to get the mean of the sampling distribution, we would add 25 plus 30 plus 35 plus 35 plus 40 plus 45 and divide the total by 6. This is really just showing 6 numbers. And to get the mean, we would add and divide by 6. This would come out to 35 because, like I said, the mean of the population and the mean of the sampling distribution of sample means have to be the same number. So if the mean of this is 35, then the mean of this has to be 35. They have to be the same number. You could try it out on your own if you like. And here's our situation 2. Once again, the mean of this and the mean of this have to be the same number. And they actually both have a mean of 35. So if you added these 4 numbers and divided by 4, you get 35. That's the population mean. If you add these 4 numbers and divide by 4, you would get 35. That's the mean of the sampling distribution. They have to be the same. Like I said, when the sample mean is being calculated, like it is in this situation, the population mean and the mean of the sampling distribution are equal. Let's go to point number 2. Point number 2 says, when a sample proportion is being calculated, the mean of the sampling distribution is equal to the population proportion. So here, what this is saying is that the mean of the sample proportions equals the population proportion. I told you that p hat is sample proportion, but regular P is population proportion. Like I said, I'll also be sharing a list of symbols for you to refer to. So let's go back to this example so I can show you what I mean here. Here we have a population that's half male. The population proportion of males is 0.5 because if you divide 2 by 4, it's 0.5. So P, the population proportion here, is 0.5 male. Now, what we have in this graph is the proportion of males in all 6 possible samples. So remember right here, this was the sample that was all female, FF. I believe it was person 3 and person 4. So that was 0. Here we have the possible sample that was all male, MM. I think it was person 1 and 2. And these are the other combinations, like person 2 and 3, person 1 and 4, 2 and 4, and so on. They were all 0.5s. So we're really just looking at the proportion of males across all 6 possible samples. If you add these 6 numbers and divide by 6, you'll get 0.5, which is the population proportion of males. Let's try it out. 0 plus 0.5, 0.5, 0.5, 0.5, plus 1 equals a total of 3. 3 divided by 6 is 0.5. So the mean of the sampling distribution is 0.5. The population proportion is 0.5. So like I said, in a sampling distribution of proportion, the mean of the sampling distribution is equal to the population proportion. And really, what these first 2 points are saying is that the possible samples always average out to the population statistic, whatever it equals. So like I said, the possible samples always average out to whatever happens to be true about the population. So if the population has a mean age of 35, the possible samples will average out to 35, right? Some will be lower than 35, some will be above 35, but they'll average out to 35. If the population is 0.5 male, the possible samples will average out to 0.5 male, or half male. That's all I'm really saying here. Let's move down. So basically, you could say that the population, you could say that even though a sample isn't perfectly accurate, even though a particular sample isn't perfectly accurate, the samples are accurate on average. In other words, they average out. When you look at all possible samples, they average out to the truth. So here, the standard deviation of a sampling distribution is called a standard error. So if you look back at each of my sampling distributions, you'll see that it has a certain amount of spread to it. So I think this first one was the most spread out. It goes from 25 to 45. Next one was less spread out, but because it only goes from 30 to 40. So there's actually a number that measures the amount of spread in the sampling distribution, and it's called the standard error. So when the sampling distribution is more spread out, the standard error is bigger. So right here, in this situation, we have a bigger standard error. The boxes are more spread out. In this situation, we have a smaller standard error. The boxes are closer together. And finally, the shape of a sampling distribution is predictable in certain situations. This point will be important in future topics. In a future topic, we'll need to predict the shape of the sampling distribution without actually creating it, without actually plotting it out. So we'll get back to this later. And finally, point number 5 says that when a sample is randomly selected from a population, the sampling distribution gives you the probability of the statistic coming out to a certain number. That's what we've been talking about all along in this video and the last video. For example, in this situation, the sampling distribution gives us these 3 probabilities right here. So yeah, that's all for this video.